What's up, everyone? It's Mr. Ramble coming at you with more science. Yesterday, we discussed the different types of heterotrophs to introduce the foundation of food webs. Food webs are a representation of how energy flows in our ecosystems, and they look a lot like this. Now, this is a food web, but what do all these arrows mean? These arrows point at where energy is flowing. To quickly recap, we should know that all energy comes from the sun as trophic energy. It is transferred to our primary producers, or our autotrophs, or organisms who produce their own stored energy. Energy then is transferred from those producers into primary consumers, and then primary consumers to secondary consumers, and etc., etc. The energy keeps moving upwards up this energy pyramid. The same goes with this food web. We see producers at the bottom as corn, flowering plants, lavenders, and mangoes. Their energy goes to the primary consumers, grasshoppers, butterflies, and fruit flies, then to the secondary ones, the thrush, dragonfly, frog, and rat. A food web and the energy pyramid resemble the same concept. They resemble energy flowing through an ecosystem. And let's not forget to mention that all organisms do die and decay, and that energy is then transferred to decomposers, another one of your type of heterotrophs that absorb and use dead organisms as their energy. This is then transferred to your producers to begin developing a cycle of energy. Today, what I wanted to add is energy can also be lost as heat, as described in this diagram that I'm showing you on my screen. Heat, as we already know, is an exothermic reaction, which means heat is going out, not in. So now we know of two ways in which energy is lost as it travels through the energy pyramid and through the food webs. And when I say traveling through, I mean going into higher trophic levels. For example, going from primary consumers to secondary consumers. We know energy is lost by either being lost as heat or being lost as being dead, going to decomposers. A third way energy is lost before moving into a higher trophic level is energy being used by that actual organism. So before energy from the primary consumers move to the secondary consumers, energy is being used by these primary consumers. So we have energy being used here, being lost as heat, and being lost as a dead organism to the decomposers. As it should already indicate, energy is lost. It is lost. It decreases as you go into higher trophic levels, which means that a python receives less energy than a rat. A rat receives less energy than a grasshopper, and a grasshopper receives less energy than the corn in this particular food web. To add what we already know about energy flow, I wanted to talk about bioaccumulation and biomagnification. This refers to the transfer of harmful pollutants, so bad pollution things, through our ecosystems, through that energy pyramid, through our food webs. Bioaccumulation, as shown in this illustration, is when a single organism or a single trophic level accumulates a harmful pollutant or product or pollution over time. For example, let's say rats are exposed to radiation over time. That is called bioaccumulation. Biomagnification, on the other hand, is when the pollutants start at the lower level trophic levels of the food web. This then accumulates through the trophic levels, and at the end, the highest level organisms, so the organisms at the highest trophic levels, have the most pollutants or the most harmful substances in them. So let's say radiation begins with corn here, and the grasshoppers then eat a lot of corn. That means the grasshoppers are getting more radiation than the corn because they're eating multiple of the corns. So all the corn have the same radiation, so corn 1, corn 2. But if grasshopper 1 is eating corn 1, corn 2, corn 3, they're getting all the radiation from corn 1, corn 2, corn 3. And then grasshopper 2 does the same thing. So let's say rat 1 eats grasshopper 1. It has all the radiation from corn 1, corn 2, corn 3, and etc. If you follow my pattern, that means that the organisms at the highest trophic level, our tertiary consumers, will have the most pollutants in them. That is biomagnification. That is what this diagram shows. So how do we stop these harmful pollutants from bioaccumulating by biomagnifying? In this diagram, we have harmful pollutants as mercury. It's a toxic substance. To stop it, humans have to intervene at the lowest trophic level. So ideally, we would start at producers, cut out all the producers with this toxic substance, with this contaminant. Then it will most likely not build up into the higher trophic levels, and it won't affect us as humans. Your homework today dives into depth about bioaccumulation and biomagnification. So remember, don't forget to submit your exit ticket by 3:30. That concludes this lesson. We've completed our objectives. Make sure to check them out on your Google Classroom, and I'll see you next time.